copying it. But when you copy a primitive, you're literally copying those 32 or those 64 bits from the right to the left. So you actually do have a true copy. The problem conceptually with a pointer is that if you literally copy the pointer 64 bits over from the right to the left, what are you getting a copy of? The address, which is not what we want because the name might mutate outside of the object itself. So copy in the sort of human what we mean sense is to actually dereference the pointer, copy the characters there into a new memory buffer and return the address of that new buffer. So it's copy in the sort of human sense, not in the super literal bitwise sense. All right, non-atomic, atomic. So if you've taken CS161 or certain other classes, and we talked about atomicity earlier in this semester in the context of database transactions. If something's atomic, it means it all happens together without interruption or not at all. Non-atomic means you have no such guarantee. In this case here, I am writing the simplest of stupidest programs called Hello World. Like, I don't have multiple threads running. There's no GUI involved here. There's no worry there's no need for atomic operations because indeed, if you do use atomic operations, let's pretend we have no idea how they're implemented. They've got to take some amount of effort, some number of CPU cycles. So why bother? If you're not in a multi-threaded environment, there's no threat of multiple threads interrupting each other. You don't need to spend those extra CPU cycles, however much they are. For more on this topic, Google the terms locks or semaphores or take CS161. All right. Lastly here, this one's obvious. Read-write means give me a getter or a setter. An alternative to this keyword is read-only, one word, and that just means give me a getter. Don't give me a setter, because I don't want the state to change. I can still initialize it with some other method, but I don't want to give it a setter property. So that's all those things mean there. So already, hopefully, Objective-C is getting kind of compelling. Let's skim to... let's do one other thing here real fast. So if you do nonetheless want to override one of these automatically synthesized setters, realize that this is possible. Notice that in version 5 here, this is identical, so no change to my declaration of a student. But if I do want to override, and this is the most clever thing I could come up with in the middle of the night, if I do want to override the setter that would otherwise get generated for me, but I still want the property, I still want my syntactic sugar and my dot notation and all of that, but I don't want the default behavior for a setter because I want to do some validation or I want to do something stupid like this, well, I can override what would have been automatically synthesized for me. And you can kind of see what this is, you can kind of infer pretty much what this thing is doing. There's some new syntax, so let's emphasize the syntax and not the functionality. So if name is equal to string. So already, if you didn't like my PHP's long function names, get ready for Objective-C's. Is equal to string : @David. So this is how you test two objects of type NSString for equality. Can't use equals because what would you be comparing otherwise? The pointers, and we learned in 50 that's very bad, right? So here's how you do it at a higher human level. All right, so if the name is equal to David, well, this appears to be changing my name to dummy, but more interesting is how is it doing that? So _name, which is the instance variable that I have told the compiler to make sure exists, even though I didn't declare it anymore in my header file. Notice now the nesting. This is an incredibly common paradigm. In Objective-C, almost always when you allocate an object, you are going to call both alloc and a method that is called init or whose name starts with the word init. Now this, of course, is in contrast to everything we've just done in examples 1 through 4, but almost where we only used an alloc method thus far for Alice, but that's because I hadn't written any init methods yet. So NSString alloc gives me a new NSString, but I immediately am going to initialize it using a method called init with string, and what string am I going to put inside of it? @ quote-unquote dummy. Where did this come from? Well, let's go back to that string reference. Init with string. There it is. So let me click on the little hyperlink there, and you can see just sort of PHP net style what's actually inside of that. Returns an NSString object initialized by copying the characters from another given string based on that signature below, and ... You can then follow along with sample code if you want. So that's just an example of referencing the documentation. So that's The only thing that's doing for us, it's allowing me to add some custom behavior. Otherwise, go ahead and actually copy it. But notice I did still have to tell the world that, you know what, I am going to adhere to copy semantics. Not assign, I'm using copy. Now, even though I'm overriding it with dummy, it's at least a unique copy of quote-unquote dummy. So it's still adhering to the notion of a copy, something that's unique only to me. Well, we can take this one step further. Let me go into example 6 here. And in example 6, we have now my own init method. So let's look at the header file here. Right, just as in PHP, we started cleaning things up. Rather than use arrow notation and the like, or setters explicitly, we kind of want the equivalent of a constructor. So again, in Objective-C, you don't really have constructors. You have a combination of alloc, which does memory allocation, and init, which does the initialization of that object. And this is why, again, they're almost always called together in one nested statement. So init with name and age. We saw this syntax before. Here's how I declare it in my H file. Notice I'm still declaring properties because I want that same dot notation ability. And now in my M file, what do I do down here? So one, I did give myself, even though I didn't declare it for some reason, an init method. So what name and age does apparently a student get if you just call alloc student init with no arguments? So apparently, John Harvard in 404, and I think I did the math correctly, based on his actual age in Wikipedia. All right, so that was like 5 minutes of my life last night. All right, so I procrastinate. So init with name is a little more compelling in that now I can specify a more explicit name and age. So how do I do this? Well, let's tease apart what's going on here. So what do you think self is referring to? Or what's it equivalent to in PHP? This, right? So this self is this, albeit with some syntactic differences. So if self equals super init. So the NSObject class comes with its own init method, and this is my way of ensuring that at least this object has been initialized however Apple wants all NSObjects to be initialized. And only if that returns a non-nil pointer, that is, it all worked, nothing went wrong, do I want to proceed to then edit the data inside of it. So self.age, notice I'm using my own properties, which is convenient. Self.age gets age, self.name gets name. And again, the only reason I can use the dot notation is why? Because now synthesized isn't the key part, the use of at property. Synthesized just means I don't have to write any of the getters or setters. Property is what gives me the dot notation there. All right, so now I can return self, and similarly here, do I return self after initializing it? Why did I not need to declare init inside of student.h? I could have, I just didn't need to. The answer lies somewhere in here. It's NSObject, right? Init is the method that, like in Java, the object class, everything has something, and everything does have this automatically, you already have this automatically, this init method. And what about ID? Why am I returning ID? What is ID? Sorry? Yeah, so it's essentially a void pointer with other features that we'll see before long, but this is just one of these conventions. I could actually say, you know what, this is a student object. It's obviously going to return a student pointer, but it might actually return nil in the event something goes wrong, and nil is not null. It's not the 0 pointer. It's actually some special sentinel that comes with Objective-C. So ID is going to allow me to sort of transcend C's very primitive handling of null pointers and now return nil potentially. So ID just means that I could return nil or a student star, or, you know, frankly, it just is easier to always say ID for all init methods because it sort of refers to whatever the object is in question. So it's part convention, but it's also part feature, but we'll see those features before long. So just to tease as to where we're going to start going with this, thus far we've just kind of tinkered around with syntax and with basic OOP functionality of Objective-C. We can start doing interesting things, and we'll start leveraging these things in the context of iOS programming quite soon. So in this example here, this is version, what was it, 7. Notice what I'm doing here is now I'm really taking advantage of the foundation framework, which comes with a whole bunch of stuff for free. Remember, in C, you get so little for free. PHP, you get like everything in the language itself. And C++, you get the standard template library, which is huge, has lots of things like linked lists and arrays and trees and all of these fancy data structures. Not arrays, all the others. And here in the foundation framework, we have NS mutable array, where NS stands for, next step, mutable just means that it's changeable. An array is an array in the normal sense. So in Objective-C, there's actually two types of arrays. There's an NS mutable array, and there's an NS immutable array, which is the opposite. It's an array, but its contents can't change once you initialize it. Now, this seems a little weird that the burden is now on you to decide, do I want mutable or immutable? And again, immutable doesn't mean empty. It just means you have to decide in advance what you're going to put in it. Why this distinction, do you think? Why are there two types of arrays in Objective-C? Or really in the iOS SDK? Or the macOS SDK here? Yeah?
Enable combiner optimizations.
Yeah, it's performance, right? So the reason is that if you know in advance, this is just a hard-coded list of things that I'm going to iterate over a lot. I don't need any sort of fancy adding or deletions. I don't need to do any memory management, therefore. And that means I can throw away a lot of potential cycles or even code. And so it's a performance detail. So if you know in advance that this array is not going to change, you might as well make it immutable. But in this case, I did decide on a mutable array. How do I allocate it? Well, again, this is the incredibly common paradigm. Even though, again, at the very start of today, we just called alloc, almost always you will call alloc followed by init or init with something, some method that starts with the name with. Notice what we can do now. The students is the variable, and it's of type NS mutable array. I can call add object. How do I create an object? Well, I can allocate a student with a name of Alice and an age of 20. I can do the same thing for Bob. And then just as in PHP and in some other languages, you have this notion of fast enumeration. You don't need to do a for loop with the I and the N and the plus plus and all that. You can just do for student S in students, greet each of those students iteratively, use our properties that we synthesized in the .m file for student, and voila, we now have sort of a function that's taking advantage not only of these OOP principles of encapsulation, also some of these Objective-C principles of like properties and the like, and we finally have the ability to express ourselves in a more interesting way than just allocating objects and greeting them. And that's where we'll pick up next Monday when we actually move all of this to the context of iPhones and iPads. See you then.